In Cartopy, I have just demonstrated you that how to use Cartopy to add some geospatial feature in Matplot, in plots generated by Matplotlib. But you can always also add geospatial feature in the hvplot functions, because hvplot also supports the use of the Cartopy or the GeoViews features. Like, I have a new term here, GeoViews. This is also a library used for geospatial processing, just like Cartopy did. So, but you don't need to, I will not introduce it here. So you just need to know about it. You don't really need to learn. Oh, of course you can learn it, yeah. But I will not introduce it in details here. So first of all, import these libraries. So this is the library that I use to plot X-array data using the hvplot function. This is the holo views and GeoViews that is wrapped by the hvplot function. Oh, and then I open data and assign these data arrays to the variables. So in this function, this is the function that we use to generate a contour line plot, right? So I have a bunch of parameters here, so I need to, okay, these are the parameters that I want to introduce here. So first of all, you need this parameter true equals to true so that the function knows this plot is a kind of geographic plot. And then you can define a projection here. It supports the use of Cartopy feature. So you can use this projection here and define this to this parameter. And then global extent, well, I will show you here. We first point here, okay? And then the coastline, of course, we need to add a coastline to the map. So you can see from here, well, just ignore the contour lines. You can see from the background of the map, you can generate the map coastlines, right? So the global extent is used to expand the plots to the whole plot range. So for example, if I comment out this global extent here, you can see the boundaries here. So let me copy it here. If you set this global extent to true, it will expand the whole plots to the whole plot range. And then here, okay, here I have, instead of adding the coastline, I also want to add some more features such as the ocean or land, or this is the country borders and rivers. Then I can use a dictionary to define it. This is the feature name. And this is the scale of the feature. So like ocean and land and borders in small scales, and you can see the borders, right? And the rivers. These are actually from the Cartopy. These features are actually from Cartopy. So you can see, although I already have the finest resolution of rivers, but it still is not as fine as it is, yeah. Okay, so, and here I want to change the map projection. I don't want to use the default one like this. This is a default one. And maybe I want to change another projection, then we just change it in this parameter. So you don't need to transform or do anything in hvplot. You just change the projection here. The function is already smart enough to help you to transform the data. So, and then here, let me see. Okay, so you have seen these lines of codes from tutorial 1. I use these codes to generate a vector field plot in hvplot. And here, okay, so the structure of hvplot is a bit difficult because if you want to make the size of arrows to depends on the magnitude of the factors, you need to have something like an option, right? Because this feature is not supported by hvplot itself. This is a feature that is supported by HoloViews. So you need to add the options here and then specify the feature that you want from HoloViews in here. So for example, here I need to specifically specify that I want the HoloViews vector field object to have its size of arrows depends on the magnitude of the arrows, the vectors. So yeah, this is a bit complicated. Yeah, maybe you can explore it. I mean, you can just follow the codes here because this is really a bit difficult to explain actually. So let me try to explain it. So in this plot, you have two overlays. The first one is the vector field plot. This is the first overlay. And the second overlay is the coastline that you just add. So in order for the hvplot function to know what function to know where to add this kind of function, you need to specifically tell the function that you want to apply this function to the vector field overlay. So yeah, I think this is, yeah. Do you have any questions about this? Or yeah, I'm trying to explain for this line of code. Or do you have any questions for this whole session? Because we're moving on almost to the next session. Okay, I think not, because none of you have a response. So let's continue because this is the last code that I want to show you. Oh, I'm sorry. So this is a tiles parameter. Well, I can, yeah. So you can see from here in the background plot, instead of the coastline, you can see a map tile here. It is a predefined map tile here. So if you check this website, yes, here it already tells you what kinds of map tiles it supports. For example, the default is Wikipedia tile. So if you make it Wikipedia, okay, maybe I try Wikipedia. Oh, it tells you it's no longer available outside Wikimedia domain. Okay. This is a kind of warning that tells you, oh, this feature may not be supported in the future, but you can use it now. So you can see I changed the map tile here. This is the map tile used by Wikipedia. And then here, because these map tiles are actually an overlay, so you can always use a star sign here to overlay a tile to your own plot. And yeah, for example, here.
Jimmy.
Hi.
Maybe you demonstrate zooming in and in so that we all know that it is something like Google Map. Zoom in and you get detail as street level.
Oh. 呢度有個颱風. Okay, here. Yeah, you can zoom into a street level. Like this is really a street level map. Well, okay. Like this is almost at most in here.